Around the 9th century AD, during China's Tang dynasty, Taoist alchemists were working on one of the most ambitious goals of their time, finding the elixir of immortality. They believed that nature still held many undiscovered secrets, and that somewhere among minerals, herbs, and chemical compounds, there might be a formula capable of extending human life. For years, these alchemists experimented with countless combinations. Ancient manuscripts were carefully studied, old recipes were copied, modified, and tested again. Each experiment was recorded, hoping that even a small reaction could reveal something new. Some mixtures produced nothing at all. Others released smoke, unusual colors, or strange odors. Most experiments ended in disappointment, but the search continued. One group of ingredients attracted particular attention because of the unusual reactions they produced when combined. These included saltpeter, a naturally occurring mineral, sulfur, and charcoal. At first, the mixture appeared ordinary, but when it was exposed to fire, everything changed. Instead of burning slowly, it ignited almost instantly. A bright flash filled the room. Thick smoke spread through the air. The reaction was far more violent than anyone had expected. Chinese writings from the period even warned that some experimenters had accidentally burned their hands, faces, and even parts of their homes while testing similar mixtures. The substance clearly wasn't the life-extending formula they had been searching for, but it had revealed something else. It could release an enormous amount of energy within a fraction of a second. The alchemists continued studying its behavior, trying to understand what made this mixture so different from everything they had tested before. At that stage, no one was designing firearms. The discovery was simply another unusual chemical reaction that demanded further investigation. Over time, this powerful mixture became known as gunpowder. Its earliest applications were surprisingly peaceful. Chinese craftsmen began using it to create fireworks for festivals, royal celebrations, and religious ceremonies. Brilliant flashes, loud explosions, and colorful displays soon became a familiar part of public celebrations across many regions of China. For several decades, gunpowder remained closely associated with entertainment and ceremonial events, but eventually another question began to emerge. If this material could produce so much force inside a firework, could that same force be used for something else? As gunpowder became more widely known, Chinese craftsmen continued experimenting with its properties. Its earliest practical use remained fireworks. Different amounts of gunpowder created different effects. Some produced bright flashes, while others generated louder explosions or larger clouds of smoke. These experiments gradually revealed that the same mixture could be controlled in different ways. It didn't take long before military engineers became interested. During the Tang and early Song dynasties, China was frequently involved in regional conflicts and border wars. Any technology that could provide an advantage on the battlefield attracted immediate attention. The first military applications of gunpowder were surprisingly simple. Instead of launching bullets, soldiers attached small gunpowder-filled tubes to arrows. Once ignited, these fire arrows carried flames far beyond the range of ordinary burning arrows. They were especially effective against wooden buildings, siege equipment, and supply camps. Soon after, engineers developed another invention known today as the fire lance. At first glance, it looked like an ordinary spear, but near the tip, a bamboo tube filled with gunpowder was securely attached. When ignited, the tube released a powerful jet of flame, sparks, and thick smoke directly toward the enemy. Historical records suggest that early fire lances were designed primarily to frighten enemy soldiers and disrupt tightly packed formations. Although the flames lasted only a few seconds, the sudden burst of fire and noise could create confusion during close combat. As blacksmiths improved their metalworking techniques, they began replacing bamboo tubes with bronze and iron barrels. Unlike bamboo, metal could withstand much higher pressure without splitting apart. This small improvement opened the door to entirely new possibilities. Instead of producing only flames, the expanding gases could now push small stones, metal fragments, or iron pellets out of the barrel at high speed. For the first time, the force created by burning gunpowder was being used to launch a solid object. The basic principle behind every firearm had finally appeared. The designs were still primitive. They were heavy, difficult to reload, and often unreliable, but they introduced a completely new idea, using rapidly expanding gas to propel a projectile through a barrel. Over the following centuries, engineers would continue improving that single concept one step at a time. The next major challenge was making these early weapons stronger, safer, and more practical for real battles. As metal barrels became stronger and more reliable, Chinese military engineers continued testing new designs. One question guided many of their experiments. What would happen if, instead of loose fragments, a single solid projectile was placed inside the barrel? The answer gradually led to the next stage in the evolution of firearms. By the late 13th century, historical records began describing weapons that closely resembled what historians now call the hand cannon. Unlike the earlier fire lance, these weapons no longer relied primarily on flames. Their main purpose was to launch a solid projectile using the expanding gases produced by burning gunpowder. Most early hand cannons were cast from bronze, although iron versions also appeared later. They were short, heavy, and far from easy to carry. Since there was no trigger mechanism, operating them required a slow-burning fuse. When the fuse reached the ignition point, the gunpowder ignited inside the barrel, producing enough pressure to send the projectile forward. By modern standards, these early firearms were inaccurate and inconsistent. No two weapons were exactly the same. Manufacturing techniques were still developing, and even small differences in casting could affect performance. Loading them also took time. After every shot, the weapon had to be prepared again before it could be fired once more. Even with these limitations, military commanders recognized an important advantage. Unlike bows, these weapons required far less training to use effectively. Training an experienced archer could take years. A soldier equipped with an early firearm could become reasonably effective in a much shorter period. As a result, armies slowly began experimenting with larger numbers of gunpowder weapons alongside traditional equipment such as bows, spears, and crossbows. For several decades, both systems existed side by side. Firearms did not replace older weapons overnight. Instead, they gradually earned their place on the battlefield as their reliability continued to improve. At roughly the same time, knowledge of gunpowder technology was beginning to spread beyond China. Trade routes connected East Asia with Central Asia, the Middle East, and eventually Europe. Merchants carried goods. Travelers exchanged ideas. Military engineers observed foreign inventions. And over time, knowledge of gunpowder crossed borders along with them. By the beginning of the 14th century, gunpowder technology was no longer limited to China. Different civilizations had started adapting it to their own needs, creating new designs and new ideas that would shape the next phase of firearm development. The story was no longer about a single invention in one country. It had become a global race to improve an entirely new kind of technology. By the late 13th century, knowledge of gunpowder had begun spreading beyond China. Unlike many inventions that remained within one region for centuries, gunpowder traveled through expanding trade networks, diplomatic contacts, and military campaigns. One of the most important routes was the Silk Road. For hundreds of years, merchants had been moving silks, spices, paper, and other valuable goods across Asia. Along with those goods came ideas, technologies, and technical knowledge. As traders, travelers, and craftsmen moved between regions, information about gunpowder gradually reached Central Asia and the Islamic world. Instead of copying Chinese designs exactly, local engineers began adapting the technology using their own materials and manufacturing methods. By the early 14th century, written records from the Middle East describe recipes for gunpowder and the construction of early firearms. Engineers refined the proportions of the ingredients and experimented with stronger metal barrels. The technology continued evolving as it spread. Around the same period, Europe also began learning about gunpowder. The earliest European references appeared during the 13th century. One of the best-known figures associated with these early descriptions was the English scholar Roger Bacon, who wrote about the explosive properties of gunpowder in his scientific studies. Within a few decades, European craftsmen started casting their own cannons. These early cannons were enormous compared to handheld weapons. Their purpose wasn't to target individual soldiers. Instead, they were designed to break through stone walls that had protected castles for centuries. Before gunpowder artillery, capturing a fortified castle often required long sieges that could last for months. Cannons changed that balance. Repeated bombardment could eventually crack walls that had once been considered nearly impossible to destroy. As a result, military architecture also began changing. Castle builders started designing lower, thicker walls that could better absorb cannon fire. Over time, the spread of gunpowder influenced not only weapons, but also the design of cities, forts, and defensive structures across Europe and Asia. Although different regions developed their own firearm designs, they all relied on the same basic principle first demonstrated centuries earlier in China. A controlled explosion inside a closed barrel could generate enough pressure to launch a projectile at remarkable speed. That single principle remained unchanged. The engineering around it, however, was improving rapidly. The next challenge was making firearms faster, safer, and far more reliable than the heavy hand cannons that came before them. The earliest firearms proved that gunpowder could launch a projectile, but they also revealed a number of practical problems. Many early weapons were heavy, reloading could take a considerable amount of time, and because they relied on a burning fuse, firing at the right moment wasn't always easy. Military engineers across Asia, the Middle East, and Europe began searching for better solutions. Rather than changing the basic idea, they focused on improving the way the weapon ignited the gunpowder. One of the earliest improvements was the matchlock mechanism. Instead of holding a burning fuse by hand, the weapon carried a slow-burning cord in a movable arm. When the trigger was pulled, the glowing end of the cord was lowered into a small pan containing priming powder. That flame then ignited the main gunpowder charge inside the barrel. For the first time, soldiers could aim more steadily while firing. Although the system was still affected by rain, wind, and moisture, it was far more practical than the earliest hand cannons. By the late 15th century, matchlock firearms had become increasingly common in many parts of the world. Armies began organizing specialized firearm units alongside traditional archers and pikemen. However, the matchlock still had an obvious weakness. The burning cord had to remain lit at all times. In heavy rain or strong wind, keeping that flame alive became difficult. It also revealed a soldier's position at night. To solve these problems, gunsmiths continued experimenting with new ignition systems. During the early 16th century, European craftsmen introduced the wheel lock. Instead of using an exposed flame, this mechanism created sparks by spinning a hardened steel wheel against a piece of pyrite. The idea was remarkably similar to the way a modern cigarette lighter creates sparks. Wheel-lock firearms were more reliable in poor weather and allowed soldiers to carry loaded weapons without constantly maintaining a burning match. However, this improvement came with a new challenge. The mechanism was extremely complicated. Each firearm required dozens of precisely fitted parts. Manufacturing them demanded highly skilled craftsmen, making wheel-lock guns expensive and difficult to produce in large numbers. As a result, they became more common among wealthy officers, cavalry units, and nobility than among ordinary infantry. Engineers continued searching for a simpler and more reliable design. That search eventually led to one of the most successful firearm mechanisms ever invented, the flintlock. It would dominate battlefields for more than 2 centuries and become the standard firearm for armies across much of the world. In the next chapter, we'll see how the flintlock transformed firearms from specialized weapons into the primary weapon of soldiers around the world. By the beginning of the 17th century, firearms had already become a common part of many armies, but one problem still remained. Every shot depended on a reliable source of ignition. Earlier systems had improved over time, but they still struggled in difficult weather and often required constant maintenance. Gunsmiths continued refining their designs until a simpler and more dependable mechanism appeared, the flintlock. Its design was surprisingly elegant. A small piece of flint was clamped into a hammer-like mechanism. When the trigger was pulled, the flint struck a hardened steel plate, creating a shower of sparks. Those sparks ignited a small amount of priming powder, which in turn ignited the main charge inside the barrel. The entire process happened in a fraction of a second. Compared to earlier systems, the flintlock was simpler, more reliable, and easier to manufacture. By the mid-17th century, it had become the standard firearm mechanism for many European armies. As firearms became more dependable, Military tactics also began changing. Infantry units were increasingly equipped with muskets instead of traditional ranged weapons. Soldiers trained to operate together in organized formations, firing coordinated volleys before reloading in sequence. Rather than relying on individual accuracy, armies focused on discipline, timing, and teamwork. Large groups firing together could create a continuous wave of gunfire that was far more effective than isolated shots. During this period, the musket became one of the most recognizable military weapons in the world. Although early muskets were still smoothbore firearms, improvements in manufacturing made them stronger, more consistent, and easier to produce in large numbers. Governments also began standardizing weapon designs. Instead of every blacksmith building firearms differently, official patterns and measurements were introduced, allowing armies to train soldiers on nearly identical equipment. This also simplified repairs and the production of replacement parts. Meanwhile, improvements in metallurgy allowed barrels to withstand greater pressure while remaining more durable over long periods of use. By the 18th century, firearms had become a central part of military organization across Europe, Asia, and many other regions. Yet one major limitation remained. Smooth barrels did not always send projectiles in a perfectly straight path. As distance increased, accuracy became less predictable. Engineers now faced a different challenge, not how to make firearms fire, but how to make them hit their target more consistently. That challenge would eventually lead to one of the most important improvements in firearm history: rifling. By the late 18th century, firearms had become more reliable than ever before. They were stronger, easier to manufacture, and widely used by armies around the world. However, soldiers still faced one major problem: accuracy. Most firearms of the time used smoothbore barrels, meaning the inside of the barrel was completely smooth. When the projectile left the barrel, it often wobbled slightly as it traveled through the air. At shorter distances, this wasn't a serious issue, but as the range increased, even small movements could cause the projectile to drift away from its intended target. Military engineers began looking for a solution. Instead of changing the projectile itself, they experimented with the inside of the barrel. Eventually, they discovered that cutting spiral grooves into the barrel produced an unexpected result. As the projectile traveled through those grooves, it began spinning rapidly. That spinning motion stabilized its flight, much like a well-thrown football or an arrow stabilized by its fletching. The concept became known as rifling. The word rifle itself comes from these spiral grooves. The improvement was immediately noticeable. Projectiles traveled with greater stability and reached distant targets with much better consistency than before. Early rifles, however, had their own disadvantages. Loading them was slower than loading smoothbore muskets. The projectile needed to fit the rifled barrel more tightly, making reloading more difficult, especially after repeated firing left residue inside the barrel. Because of this, smoothbore muskets remained the standard weapon for many armies well into the early 19th century. Over time, improvements in ammunition solved many of these problems. One of the most significant advances came with the development of the Minié ball during the mid-19th century. Its design expanded slightly when fired, allowing it to engage the rifling while still being relatively easy to load. This innovation combined faster loading with much greater accuracy. As a result, rifles gradually replaced smoothbore muskets in military service across much of the world. The change also influenced military tactics. Battlefields that had once relied on tightly packed formations became increasingly dangerous. Since soldiers could now engage targets accurately from much greater distances, armies began spreading out instead of standing shoulder to shoulder. Defensive positions, field fortifications, and cover became more important than ever before. Firearm technology had entered a new phase. Engineers were no longer focused only on reliability. Now they were asking a different question. Could a firearm be designed to fire multiple shots without stopping to reload after every single one? That question would define the next chapter of firearm development. By the middle of the 19th century, rifles had become far more accurate than the firearms that came before them. But another challenge still remained. After every shot, the shooter had to reload before firing again. Even with years of training, that process took valuable time. Engineers and inventors across Europe and North America began searching for ways to reduce that delay. Instead of redesigning the barrel, they focused on the ammunition itself. For centuries, firearms had required several separate components. Gunpowder, the projectile, and the ignition source all had to be loaded individually. This made the process slow and complicated. During the 19th century, these separate components were gradually combined into a single self-contained unit known as the metallic cartridge. It packaged the projectile, the propellant, and the ignition system together inside a metal case. This simplified loading, improved reliability, and made ammunition easier to transport and manufacture. The introduction of metallic cartridges opened the door to entirely new firearm designs. Inventors soon developed mechanisms capable of loading the next cartridge much more quickly than before. One important example was the lever-action rifle. Using a lever beneath the firearm, the empty cartridge case could be removed and a fresh cartridge loaded in a single movement. Around the same period, another design appeared, the bolt-action rifle. Its strong locking mechanism made it exceptionally reliable and accurate. By the late 19th century, many national armies had adopted bolt-action rifles as their standard military firearm. These improvements were supported by another major development taking place around the world, the Industrial Revolution. Factories equipped with precision machinery transformed the way firearms were manufactured. Instead of being built almost entirely by hand, many components could now be produced with consistent dimensions. This also encouraged the widespread use of interchangeable parts. If one component became damaged, it could often be replaced without rebuilding the entire firearm. Production became faster, quality became more consistent. Large numbers of nearly identical firearms could now be supplied to military forces. By the end of the 19th century, firearm technology had advanced dramatically compared to the early hand cannons of medieval China. Yet inventors were still working toward one final goal. They wanted firearms that could continue firing repeatedly with even less manual effort. Achieving that would require an entirely new way of using the energy produced by each shot. That innovation would lead to the development of semi-automatic and fully automatic firearms. As firearm technology continued to evolve, the next era brought semi-automatic and fully automatic firearms. Instead of manually preparing the weapon after every shot, engineers learned how to use the energy produced by firing itself to automatically cycle the mechanism, making firearms faster and more efficient than ever before. Over time, this technology led to the development of many modern firearms, including bolt-action rifles, assault rifles, machine guns, and modern handguns, each designed for different purposes and continuing to evolve even today. And with that, our journey comes to an end. It's incredible to think that this entire story began over 1,000 years ago when Taoist alchemists in ancient China were searching for the elixir of immortality. Instead, they accidentally discovered gunpowder, a discovery that would eventually transform military technology and reshape human history. From a small laboratory experiment to the world's first firearms, and finally to the modern weapons we know today. That's the remarkable journey of firearm evolution. If you enjoyed this documentary, don't forget to subscribe and let us know in the comments which invention you'd like us to explore next. Thanks for watching.